middleware today. So a rational expression is an expression of the form polynomial over polynomial. So in other words, a rational expression is just a fraction. But these are algebraic fractions, so they have letters on the top and bottom. So polynomial expression over polynomial expression. We got some extra pencils up there too. Spring colors, yellow, purple. So rational expression is just an expression of the form polynomial over polynomial. What we're going to be doing in this lesson is using our factoring skills to simplify these rational expressions. That's the goal here. And in this case, simplifying, you got it? Simplifying will mean canceling. So it's canceling, but it's canceling in algebra, not with numbers. It's with numbers and letters. So canceling is, there's one little prerequisite here. It's you can only cancel quantities being multiplied. So the idea, what you really need to understand, you can even write this in your summary, is factor first. Do not jump right into canceling unless the polynomial on the top and the bottom are in factored form. So you can only cancel quantities being multiplied. And I'll show you what I mean by that with these three little examples here. So we have 3x to the fifth and 9x. When I have a number written next to a letter, that means these are being multiplied, right? In algebra, 3x to the fifth means multiplication. There's no plus or minus sign between the 3 and the x to the fifth, nor between the 9 and the x on the bottom. So we can cancel these. And the way it works is this. 3 goes into 3 once and into 9 3 times. And then you have to ask yourself, how many more x's are on the top in this expression than on the bottom? Yeah, that's right, 4 of them. So I'll have x to the fourth left on the top and 3 on the bottom. Some students will do this. Cancel that. That's just a 1. But there are 4 more x's on the top than on the bottom. So your final answer is x to the fourth over 3. In this case, what makes that simplified is that I've reduced the fraction and there's less variables there. There's no longer an x on the top and an x on the bottom. Now here, this is where this really comes into play, and you've got to really key in on this. I cannot cancel the 12 and the 4. I cannot cancel the 12 and the 4. Why is that? They have different signs, but what are the signs in front of them? This is a... They're not being multiplied. They're being subtracted or added. Yeah. So that's the key on here is don't fall in a trap. If you're jumping right into the step of canceling, you're probably doing something wrong. There should be some kind of factoring that happens first. Just remember factor first. If you could write on your summary guide right now, factor first, that would help. So can I factor the top of this at all? X minus 12, is there any common factor that goes into both x and 12 besides 1? No, there's nothing, right? So we just have x minus 12. What I like to do is put parentheses around that. I'll show you as we get into this why. The bottom here, is there anything that I could do to factor that? 3x and 4. Anything common to 3x or 4? Besides 1, no. So I just have 3x plus 4. And so you take them as full units. X minus 12, 3x plus 4. Unless these match, you cannot cancel them. Okay, so there's no canceling that can happen in this problem. It's as simple as it can be. What about this one right here? Is there any canceling that can be done in that third one? There's a little bit. What do parentheses mean here in terms of operations? Multiply. So they are being multiplied. The 5 times the x plus 2, and then you got 5 times the 7x plus 2. So it's already in factored form or multiplication form. So you can cancel the 5s, that equals 1, and you're left with x plus 2 over 7x plus 2. And you cannot cancel the 2's. As much as you may want to, if you think of it this way, if I canceled the 2's and I canceled the x's, I'd be left with 1 7. That'd be like saying, I don't care what you plug in for x in this expression, it's always equal to 1 7, which doesn't seem to make sense. You can't cancel the 2's and the x's in this one. So you just leave it like that. So only cancel quantities being multiplied. We're going to start with GCF factoring. So always look for a greatest common factor first. So on this top part here, is there a greatest common factor between x and -1? Aside from 1 or besides 1. If there isn't, you just write x minus 1, and I'm going to put it in parentheses. What about on the bottom? Is there a greatest common factor on the bottom? Is there a number that you could divide each of these by and simplify it? You could. So you write the 5 out in front, and then you do your division. This goes back to skill 14, where you divide that greatest common factor into each term, and what is left over here, 5x divided by 5 is x, and 5 divided by 5 is 1, and there's a minus sign in between. And some of you might find this actually kind of fun, because when you go and you have a match, it's like, oh, I got a match. You're playing memory. Did you get a match? You cancel your match. That's 1 and 1, and so this ends up being 1/5. Notice that the 5 is on the bottom. But would you agree 1/5 is simpler than what we started with? It is simpler. But you got to be careful about your factoring here and canceling. Problem 1 is probably the most difficult one for students here. There's just, when it comes to greatest common factor, pulling that out, it's almost harder than factoring quadratic trinomials into parenthesis things. So there's lots of different types of examples. Let's look at each one here. 21a squared over 7a cubed. 21 and 7 will simplify to 3 over 1. And then you have to ask yourself on the a's, where are there more a's and how many more? On the bottom, and how many more? 1. So we got 3 over a. You can, and you may have done this before, some students will do is write out all the a's. It's a little ridiculous if there are a lot of very high powers. But you write out all the a's and you start canceling the matches, right? And that shows you the 1 that's left in the bottom. That's probably how you did it in elementary school. With numbers, you probably wrote them out and you start canceling them maybe. The 3 over a is it. Second one on here, 2n minus 3. There's no GCF for 2n minus 3, so I just place it in parentheses. But 6n minus 9 has a GCF. Right? 3 will go into each of those. So I'll pull out a 3. Divide that by 3 and that by 3. 6n divided by 3 is 2n, and 9 divided by 3 is 3. And what we should not be surprised about on these is that when you pull out a greatest common factor, you get some other factor that matches. At least 99% of the time, aside from this one example right here, this is the only one that hasn't been able to be simplified so far. But the majority of these, you will find something that can be canceled out. In this case, it's the 2n minus 3, which leaves us with 1 on the top and 3 in the bottom, so 1/3. Right, so we have 18x squared right here. And then on the bottom, I can factor something out of the bottom. Looks like I can take a 4 out. And to figure out what's left over, I divide each term by 4. So 4x divided by 4 gives me x, and 8 divided by 4 is 2. And I can't do any canceling with the x squareds or the x's because this x plus 2 is part of a package deal. It's a binomial factor, and it does not divide into the x squared. But the 18 and the 4 does simplify. 2 will go into 18 9 times and into 4 twice. And so I'm left with 9x squared over 2 and then x plus 2. And it's fine to just leave your rational expression in factored form. You don't need to multiply the 2 or distribute it to the x plus 2. Just leave it 2 and then x plus 2. Makes it nice to have it in factored form. As we move into algebra 2 and you do these, you'll actually be finding where the bottom equals 0, because that's called a vertical asymptote. So it's kind of nice to have it in factored form, because then when it's in factored form, you use what we did last chapter, the zero product property, to set this equal to 0 and find where the bottom one equals 0. And there's a place where there's what we call a vertical asymptote. You'll learn about those as you move into algebra 2. So what about this one? What's the greatest common factor of the top here? It's not real obvious. There's definitely an x that shows up in each. What do you think about the number 91? Do you think that 91 and 26 have anything in common? So we got something x. They do have something in common. Here's the deal. I'm thinking that perhaps whatever comes out of each of these will create a 2x squared plus 7. We'll see. So 26 has its factors 2 and 13. That's it. 2 doesn't go into 91, but 13 does go into 91. 7 times. So we've got a 13x that we pull out, 2x squared plus 7. That's convenient. A lot of the problems they give you in here, there will be a match top and bottom. So just that can help you into the factors. You kind of know what to expect. So you can cancel here, and we're left with 13x. So honestly, I think problem 1 has the ones that students struggle with most on. It gets easier. Any questions on any of those? I guess the moral of the story here is pull out the GCF. And when you pull out the GCF, expect what's left over maybe to match what's on the bottom. Okay, at least to some degree. And you can cancel it. All right, we'll go on to problem 2. Problem 2 requires factoring top and bottom. So the top I can factor out of 3. This is equal to 3, and then I'm left with x minus 2. So you divide the 3 into each of these. And then the bottom requires me to factor a quadratic trinomial. So I'm looking for 2 numbers that multiply to equal -6 and add to equal 1. You think of 2 numbers that multiply to equal -6 and add to equal 1.
3 and negative.
Yeah, 3 and -2. And I'm not surprised that one of them is -2. That's not surprising, because when I write down my factors, x plus 3 and x minus 2, remember, we're not solving these. We're not looking for the solutions. We're just factoring it. So my factors are x plus 3 and x minus 2. And the purpose of factoring is to see what can cancel. And here the x minus 2's can cancel, leaving just 3 over x plus 3. And that's the simplified version of that rational expression. So each one of these 4 in the now you try can all be factored. Believe it or not. So I'm going to give you a few minutes just to see how you do on factoring these. And then I'll follow up and give you solutions. So let's pause this. It's going again here. All right, so as you guys are trying these, I've boxed the solution, so hopefully you're able to factor each of these and then cancel, and you should end up with what I have boxed on here. So let's do this last one. We've got, how do I know it's going to look like this for this last one? I did 2 sets of parentheses. How do I know that? Yeah, they're both trinomials. So I know that. I bet at least one of them will match. What'd you get for factors on the top here?
So C minus 3 and C plus 2.
Okay. And it looks like on the bottom they're both pluses, huh? C plus 2, C plus 3. Yeah. Good. And the C plus 2's cancel. And then you have to resist the urge to do any more canceling that is not allowed. Okay, I have a lot of students, guys, right here. I'm sure you wouldn't do this, right? But a lot of students want to just cancel everything here, and you cannot do that. You can't cancel the 3's, you can't cancel the C's. Because of what? if this were C times 3, or C, you know, top and bottom, then that would be fine. But because of the minus and plus sign there, you can't do it. So that's it. Any questions on these? So it's just factor first and then cancel and expect to cancel, right? All right. Last problem on here. This one is, let's do this. Do you guys recognize 4 minus x squared? It's one of the special cases. How do we factor 4 minus x squared? Do you remember? What kind of term is 4 and what kind of term is x squared? They're special. What's that? They're a different R word. They're square roots or radical. Like you can take the square root of each one. They're perfect squares. So the square root of 4 is 2, and the square root of x squared is x. So this is called a difference of squares. It would factor like this: 2 plus x and 2 minus x. So it's kind of backwards. Usually we have the x's first, right? Usually the x's first. So it's, but that'll work. And then on the bottom, what's the greatest common factor on the bottom here? 7. And that leaves me with x minus 2. So here's the deal. I really would like to cancel the 2 minus x and x minus 2. They almost look like they match, but they don't quite. So there is one little trick you can do. You may have seen this before to make them match. Here it is. The 2 plus x I'm going to leave alone, but the 2 minus x, I can change that up by factoring out a negative 1. So if you take a negative 1 out of there, it will leave you with, ladies, you got to watch this carefully here. When you see something like this where you have a 2 minus x and an x minus 2, in other words, they're the same numbers in parentheses, but they have opposite signs, you factor out a negative 1, and it will change the 2 to a negative 2 and the negative x to a positive x. So you factor out a negative 1, and then you leave it alone on the bottom here. And now I can cancel out the x minus 2's. So the only thing that changes is I factor out a negative 1. And so my final answer will have a negative out in front of it, a negative 1. 2 plus x over 7. I think you'll recognize these because you'll see that the number comes first. See in these, the numbers come in first. So you can go right to factoring out a negative 1 on the bottom here. If I factor out a negative 1 on the bottom, this first one here, how does that change my factor 4 minus y when I factor a negative 1? My question is, if I factor a negative 1 out of 4 minus y, it's like dividing by a negative 1. How does that change my factor? What's my new factor? Yeah, if it's now a negative 4 and a positive y. And that'll be convenient because how does y squared minus 16 factor? There's a bunch of these in your classbook. It's another difference of squares. Difference of squares. So it's going to factor as y plus something, y minus something. What's the something here? Y squared minus 16. This is one we got to be able to recognize. It's a difference of 2 perfect squares. So it'll always factor as y plus something, y minus something. What's the something here? Yep, it is 4. Okay. Y minus 4, y plus 4. And I'm not surprised because I have a y minus 4 on the bottom. So that's what will cancel. leaving me with just y plus 4 over negative 1. Or you could put the negative out in front. All right, the second one on here, it's backwards again. We've got the letter second, the number first. You don't always have to just plot a negative one. In this one, if I want to, I can plot a negative 3. If I divide 3 by negative 3, that gives me a negative 1. And negative 9x divided by negative 3 is a positive 3x. So I can also take out other negative numbers besides negative 1 if there's a bigger term that will come out. And then this 6x squared plus x minus 1 is a quadratic trinomial. I've got to find factors of negative 6 that add to equal 1. And then not forget to divide through by the 6 to get my factors. So I've got, well, how about 3 and, well, that won't work. 3 and negative 2, yeah, that'll work. 3 and negative 2 multiplied equal negative 6 and add equal 1. And then I got to divide each one by 6. And then reduce it. So this is negative 1/3. And this is 1/2. And then bring the bottom number up, pair it with x. So I've got 2x plus 1. Sometimes I've had students that will actually write this in from the beginning, put the x in there. Maybe that'll help you to remember to bring the bottom up. You pair the x with the bottom. That'll help you. You don't really need it there. You just got to translate it correctly here. But the other one is 3x minus 1. And 3x minus 1's cancel, leaving negative 3 over 2x plus 1. So that's our final answer. So that one is the factor out the negative trick. This last one, 2x minus 5, I'm going to leave it alone. But if I factor a negative 1 out of the bottom, I'm then left with 2x minus 5. And so the 2x minus 5's cancel, leaving me just negative 1. All right. So you could just write your summary. It's something along the lines of factor first, and then cancel. But simplifying rational expressions,